Hello all, welcome to the Empirical and Molecular Formulas podcast. Thought we'd start with a little joke, so I'll give you a second to read it. Thought it was kind of cute. Hopefully you're past that point though. Alright, so we're going to be talking about empirical and molecular formulas. An empirical formula is the lowest whole number ratio of the elements in a compound, while the molecular formula is the actual number. Now, it could be the lowest whole number ratio, or it could be a multiple of the lowest whole number ratio, a multiple of the empirical formula. So sometimes they're the same, sometimes they're different. Here are some examples. Okay, so here you see molecular formulas. So the molecular formula of carbon dioxide is CO2. So you got 1 carbon to 2 oxygens. So you see that the coefficients 1 and 2 are not divisible by anything other than 1. So the empirical and molecular formula are the same in this instance. Now the next one down, you have H2O2, hydrogen peroxide. And you see they both have a 2 as a subscript. So both of those could be reduced to 1 to 1. So here's the molecular, and the empirical is the lowest whole number ratio. Another example, we have carbon 4, H8, O2. You see that all of these little subscripts are divisible by 2, so we could reduce them to C2H4O. Okay, so empirical is the lowest whole number ratio, molecular, what you see in nature. Alright, to find the empirical formula, you have to follow these steps. First, you change your grams to moles. Then you're going to divide by the lowest number of moles. Then you will round or multiply that to get whole numbers. And these numbers will become the subscripts for the element you're solving for. Now, on number 3, this little multiply tip, you might need to come back here sometime during the video or in the future if you get confused. Alright, if you get a decimal of 0.5, we know that 0.5 is the common fraction, 1/2. Okay, so in this case you're going to multiply by 2 to get rid of it. Okay, see? Okay, the fraction, or the decimal 0.3, that is the common fraction, 1/3. So you will multiply by 3, the denominator, to get rid of it. Now if you have 0.25 or 0.75, those are the common fractions 1/4 and 3/4. And so you again multiply by the denominator to get rid of that. Now I know this is all hogwash right now, but it'll make sense in a minute. Alright, now I've got to figure out how to change the slide. Oh, okay. I think I got this. Wait, I need the mouse. There we go. Okay. Alright, so this problem, what is the empirical formula of a compound that is 25.9 grams of nitrogen and 74.1 grams of oxygen? Alright, so we're going to start with our nitrogen. The first step was take the grams and convert it to moles. Alright, so you got grams on top, so you got to put grams on the bottom, and it would be the molar mass of nitrogen, and 1 mole on top, so that cancels your grams. Alright, and then you've got your answers, 1.85. Alright, now you got to go do the same thing for oxygen. Okay, oxygen is 74.1 grams. Let's see if I can drag this little thing over. Whoop, there it goes. Okay. Alright, and again, we're going to take it to moles. So we have grams on the bottom, and that would be the molar mass of oxygen. 1 mole on top. Grams cancel. Alright, and here we get 4.63. Okay, the next step was look at your numbers. Which one's the smallest? This one's the smallest. Okay, so now you're going to divide both of these numbers by the smallest number. Alright, So you get 1 up here. And then down here you get 2.5. All right, so 2.5, that's the common fraction, 1/2. So we're going to multiply both of these numbers by 2 to get rid of a half, because you can't have a half of an oxygen atom, right? Makes no sense. You got to multiply by 2, everybody by 2, and get rid of that little half of an atom that can't really exist. So you got 2 and 5. So you got N2, and then O, oxygen, 5. Okay? All right, now let's learn how to find the molecular formula. So first you want to calculate the mass, the molar mass of the empirical formula, which is what we just learned how to find. Then you're going to take the molecular molar mass, which will be given to you always, and you're going to divide by the empirical molar mass that you just found. You'll get a number. That number will then be multiplied by your empirical formula, and that will get you your molecular formula. All right, so let's make sense of this. All right, so calculate the molecular formula of a compound whose molar mass is 216.03, and it has an empirical formula of N2O5. Well, hopefully you noticed that that's what we just found the empirical formula of. So we're going to calculate the molar mass of that real quick. Okay. All right. And that gives us, let's see, we got 80 and 28.014. Add those numbers up, and you get 108.014. All right, now, next step. Take your molecular molar mass. All right, divide by the molar mass of the one you just found. Okay, and you get 2. Now you take your 2, multiply it by the subscripts in your empirical formula. So you get N4O10, and that is your molecular formula right there. All right, let's try one last problem. Now this one wants us to combine molecular and empirical formulas, so it wants us to find both. All right, so we're given 40.68 grams. Okay, this is carbon. Okay, so we're going to take it to moles. All right, so I'm putting the molar mass of carbon on the bottom. Okay, and I get 3.39. All right, now I'm going to take my hydrogen. All right, I got 5.08 grams. All right, take this one to moles. Okay, all right, now take the oxygen. Okay. All right, now, next step. You pick the lowest of the numbers, okay? So here's your first one. All right. So we're going to divide everybody by that lowest number, which, lucky for us, 2 of them ended up with the same answer. Okay. All right, so then we got that 0.5 again. So we got to get rid of it. We got to multiply everything by 2. Okay, now, and if that was 0.25, we'd be multiplying by 4. And if that was 0.75, we'd be multiplying by 4. And if it was 0.3 or 0.6, we'd be multiplying by 3. Okay, but we'll be practicing those more in class too. All right, so these numbers become your subscripts. So you got C2H3O2. Okay, so this is your empirical formula. All right, now we need to find the molar mass of this. So we got 2 times 12.011, 3 times 1.0079, and 2 times 16. Okay, and we're going to add all that up. All right, and we get 59.0457 grams. All right, then you take your molecular molar mass, divide by the empirical molar mass, and then you multiply that by the empirical formula, and that gets you the molecular formula. All right, so that concludes our empirical molecular formula podcast. Please write down any questions you have and bring them to class. See you then.